Let me tell you about a number. 299,792,458 meters per second. That is the speed of light in a vacuum, not approximately. Exactly. So exact that since 1983, we do not measure this number anymore. We define the meter based on it. The meter is now, by definition, the distance light travels in 1/299,792,458th of a second. Think about that for a moment. We have reversed the logic. We are not measuring how fast light goes. We are using light speed to define what distance means. And here's the thing. This number, this seemingly arbitrary velocity, is not really about light at all. It is a property of space-time itself. It is the conversion factor between space and time. It is the maximum speed at which anything, information, influence, cause and effect, can propagate through the universe. Well, the first thing I have to tell you is that you probably wonder why there is a speed limit at all. Why can you not just keep accelerating something faster and faster indefinitely? You push harder, it goes faster. Push harder still, it goes even faster. What stops this? What makes 299,792,458 meters per second special? The answer reveals something profound about the structure of reality itself. Now, let me tell you what happened in 1887. There were two physicists, Albert Michelson and Edward Morley, very careful experimenters. They were trying to measure something that turned out not to exist. They wanted to detect Earth's motion through what people called the luminiferous ether, this invisible medium that everyone assumed light waves must travel through. You see, at the time, physicists thought light needed something to wave in, the way sound waves need air. And if Earth is moving through this ether, then light should travel at different speeds in different directions, depending on whether you are moving with the ether or against it. So Michelson and Morley built this beautiful apparatus, very precise. They measured the speed of light going north, south, and east, west, and they found, to their complete confusion, absolutely no difference. Light travels at the same speed regardless of the direction you measure it, regardless of how Earth is moving. This was bizarre. Think about ordinary velocities. If you are driving toward another car at 60 miles per hour, and that car is driving toward you at 60 miles per hour, you approach each other at 120 miles per hour. Velocities add. That is common sense. That is how the world works. But Michelson and Morley found that if you fly toward a beam of light at half the speed of light, the light still approaches you at full light speed. Not 1.5 times light speed, just light speed. The same speed you would measure if you were standing still. This made no sense at all. And then, in 1905, there was Albert Einstein. Young fellow working in a patent office. He took this bizarre experimental result seriously. He said, all right, suppose it is true. Suppose the speed of light really is the same for all observers, no matter how they are moving. What does that mean for everything else? What it means is that everything else has to change. Time, length, mass, even the concept of simultaneity. All of it becomes relative. The only thing that stays constant is the speed of light. You see, Einstein built special relativity on two principles. First, the laws of physics are the same in all inertial reference frames. There is no privileged position, no absolute rest. Second, the speed of light in vacuum is the same for all observers, regardless of their motion. From these two principles, everything else follows. And what follows is very strange. Now, here is what happens when you start moving very fast. Time slows down. Not in your experience, you feel perfectly normal. But from the perspective of someone watching you, your clock ticks more slowly than theirs. This is not an illusion. It is not a measurement error. It is how time actually behaves. There is a number physicists use, the Lorentz factor, gamma. It is gamma equals 1 divided by the square root of 1 minus v squared over c squared over c squared. When you are moving slowly, gamma is very close to 1. Time runs normally. But as your velocity v approaches the speed of light c, gamma grows larger and larger. At 86.6% of light speed, gamma equals 2. Your clock ticks half as fast as a stationary clock. At 99.5% light speed, gamma equals 10. Your clock ticks 1/10 as fast. And as you approach light speed, gamma approaches infinity. Time nearly stops. This is not theoretical. We measure this every day in particle accelerators. Let me tell you about muons. Muons are particles created when cosmic rays hit the upper atmosphere, about 10 kilometers up. They are unstable. In their own rest frame, they decay in 2.2 microseconds. That is their lifetime. Now, these muons travel down toward Earth's surface at 99.94% of light speed. At that speed, in 2.2 microseconds, they should travel only about 660 meters before decaying. They should never reach the ground, but they do reach the ground. We detect them at sea level all the time. Why? Time dilation. In the laboratory frame, in our frame, their lifetime stretches to about 64 microseconds because of their high speed. That gives them enough time to travel the full 10 kilometers. In the muon's own frame, something different happens. The atmosphere is length contracted to about 660 meters, so they reach the ground before they decay. Either way you calculate it, lab frame or muon frame, they reach the ground. The numbers work out exactly. Special relativity predicts this. Experiments confirm it to extraordinary precision. And here is where it gets very interesting. You might think, alright, time slows down at high speeds, lengths contract, but surely if I just keep accelerating, I can eventually reach light speed. Just keep pushing, keep adding energy. No, you cannot. And the reason why reveals the true nature of the speed limit. You see, in Newtonian mechanics, kinetic energy is 1/2 mv squared, mass times velocity squared. If you double the speed, you quadruple the energy required. But the energy is finite. You can always add more. In relativistic mechanics, the kinetic energy is gamma minus 1 times mc squared. As velocity approaches c, gamma approaches infinity. The energy required diverges. It becomes infinite. Think about what this means. To accelerate an electron to 99% light speed takes a certain amount of energy. To reach 99.9% takes about 10 times more energy. To reach 99.99% takes another 10 times more. Each additional decimal place costs exponentially more. To reach exactly light speed would require infinite energy. The universe does not have infinite energy, therefore nothing with mass reaches light speed. At CERN, the Large Hadron Collider accelerates protons to 99.99991% of light speed. That is 7 nines. The protons are moving so close to light speed that it takes them only about 90 microseconds longer to complete the 27-kilometer ring than it would take light itself. And each incremental increase in speed toward that limit costs enormous amounts of energy. They are pushing against an asymptote. They can get closer and closer, but they can never actually reach it. The speed of light is not a barrier you hit, like a wall. It is an asymptote you approach but never touch. Now, you might ask, well then, how does light travel at light speed? What makes light special? And the answer is beautiful. Light is not special. Mass is special. Photons, particles of light, have zero rest mass. Zero. And because they have zero mass, they must travel at exactly light speed. They cannot go slower. They cannot stop. Stopping would mean zero energy, which means non-existence. There is an equation in relativity that relates energy, momentum, and mass. E squared equals pc squared plus mc squared squared. Energy squared equals momentum times light speed squared plus mass times light speed squared all squared. For a photon, mass m equals 0, so the equation becomes E equals pc. Energy equals momentum times the speed of light. The photon has energy and momentum but no rest mass. A massless particle must travel at the invariant speed c in all reference frames. It has no choice. It cannot slow down. It cannot speed up. It always moves at c. So the speed of light is really a misnomer. If we discovered tomorrow that photons actually have a tiny mass, they would travel slightly slower than c. The fundamental constant of the universe would still be c, this maximum speed, but we would have to stop calling it the speed of light. We would call it something else. The speed of causality, maybe. The invariant speed of space-time. because that is what it really is. It is the speed at which causality propagates, the maximum rate at which information or influence can travel, and this brings us to the deepest reason why the speed limit exists. It exists to preserve cause and effect. Just imagine that you could send information faster than light. You send a signal from Earth to a spaceship 10 light years away, but somehow it gets there instantly. From your perspective, you sent the signal at noon on Monday, and it arrived at noon on Monday. Instantaneous. But now think about this from the perspective of someone moving relative to you. In special relativity, different observers in relative motion disagree about what events are simultaneous. What you call at the same time depends on your state of motion. So an observer moving at high speed relative to Earth might see that signal arrive at the spaceship before you sent it from Earth. They would see the signal arrive on Sunday and then see you send it on Monday. Effect before cause. And if that observer could send a signal back to you, also faster than light, also instantaneous in their frame, that signal could arrive back at Earth before you originally sent the first signal. You could receive a reply before you sent the message. You could send information into your own past. This creates paradoxes, grandfather paradoxes. You could send yourself a message telling yourself not to send the message. Logical contradiction. The universe does not allow this. In special relativity, events are separated by intervals. If two events are close enough in space and far enough apart in time that light can travel from one to the other, we say they are time-like separated. These events have an observer-independent causal order. All observers agree on which happened first. If two events are far apart in space and close together in time, so that light cannot travel from one to the other, we say they are space-like separated. These events have no definite temporal order. Different observers disagree on which happened first. The speed limit is what creates this structure. It is what protects causality. If you could travel faster than light, you could connect space-like separated events. You could create causal loops. You could create paradoxes. The universe forbids this not by force, but by geometry. Space-time is structured so that faster-than-light paths do not exist. There is no pathway through space-time that gets you there faster than light, any more than there is a path that takes you north of the North Pole. The geometry does not allow it. And you know what? This is not just about special relativity. Even in general relativity, Einstein's theory of gravity where space-time can curve and warp, the local speed limit remains. Near a black hole, space-time is curved drastically. Time runs slower, distances are stretched, but light still moves at c locally. The speed limit is built into the fabric. When LIGO detected gravitational waves in 2015, waves from two black holes colliding 1.3 billion light-years away, those waves traveled at the speed of light. Exactly. Gravitational waves, ripples in space-time itself, propagate at c. Not faster, not slower. The same speed. Now let me tell you something else. The speed of light appears everywhere in physics. Not just in electromagnetism, where it is the ratio between electric and magnetic field units. Not just in relativity, where it is the conversion between space and time. It appears in quantum mechanics. It appears in thermodynamics. It is in the equation E equals mc squared, Einstein's most famous equation, which tells us that energy and mass are equivalent, convertible, at the rate of c squared. It is in the fine structure constant, the dimensionless number, that characterizes the strength of electromagnetic interactions. That constant involves c. It is in the equations governing how particles decay, how fields propagate, how quantum information spreads. The speed c is not just the speed that light happens to travel, it is a fundamental constant defining the geometry of space-time. It sets the scale for how space and time relate. It determines the maximum rate of change, the fastest that anything can happen. Richard Feynman, a very brilliant fellow, said it beautifully. The speed of light is not about light. It is about the structure of space and time. Think about what this means. You have probably heard that nothing can go faster than light, and you think, well, that is a rule, a law of physics, something imposed. but it is not imposed. It is not like a traffic law, where you could break it if you had a faster car. It is geometric. It is like saying you cannot have a triangle with four sides. The structure does not allow it. Space-time is built in such a way that c is the maximum, not because anything enforces it, but because that is the shape of reality. Every limit reveals a deeper structure. The fact that you cannot cool anything below absolute zero reveals the quantum nature of energy. The fact that you cannot know both position and momentum precisely reveals the wave nature of matter. And the fact that you cannot exceed the speed of light reveals that space and time are not separate, that causality is geometric, that the fabric of reality has a built-in maximum rate of change. You cannot exceed it because it is not really a speed, it is the shape of existence itself. Now, there is something I want to tell you about how we know this, how we have tested it. Because this is not just theory, this is measured, confirmed, tested to incredible precision. Physicists have looked for violations of the speed limit. They have tested whether light might travel at different speeds in different directions, whether it might travel faster in some conditions, whether particles might, under extreme circumstances, exceed it. They have found nothing. Every test confirms that c is constant, invariant, universal. The Lorentz invariance, the principle that the laws of physics look the same in all inertial frames, has been tested to 1 part in 10 to the 21st power. That is precision down to 21 decimal places. No violation found. We have sent atomic clocks on airplanes, flown them around the world, and brought them back. When they landed, the clocks disagreed with clocks that stayed on the ground, by exactly the amount predicted by relativity, accounting for both the speed of the airplane and the difference in gravitational field strength at altitude. Time dilation, measured directly with clocks you can hold in your hand. We have GPS satellites orbiting Earth. These satellites have clocks on board. If we did not account for relativity, both special relativity because the satellites are moving and general relativity because they are higher in Earth's gravitational field, the GPS system would accumulate errors of about 10 kilometers per day. It would be useless. The fact that GPS works, that it gives you your position to within meters, is a daily confirmation of relativity. Every particle accelerator on Earth operates based on relativistic mechanics. The engineers designed the magnets, the beam paths, the collision points, using relativistic formulas. If those formulas were wrong, the particles would not go where predicted. The detectors would miss the collisions, nothing would work. But it all works precisely because the theory is correct. The speed limit is real. It is tested. It is confirmed every day in thousands of experiments. And here is something that I find beautiful. The universe could have been different. The fundamental constants could have had different values. The speed of light could have been faster or slower. But whatever value it had, it would still be the maximum speed. It would still be the conversion factor between space and time, because that is what the structure requires. In our universe, c happens to be about 300 million meters per second. In some other universe with different physics, it might be different. But the role it plays, the fact that there is a maximum speed, a conversion between space and time, that is not arbitrary. That is structural. Some physicists think about this in terms of units. We measure speed in meters per second. But meters and seconds are human conventions. We invented the meter. We define the second based on atomic vibrations. These are arbitrary choices. In fundamental physics, you can choose units where c equals 1, just 1, not 300 million of anything, just 1. In these units, space and time have the same dimensions. A light year is not a distance that light travels in a year. It is just a year. Time and distance are measured in the same units because they are aspects of the same thing, space-time. In these units, the speed limit being 1 means that the maximum rate of change in space per change in time is 1 to 1. You can trade space for time at a 1 to 1 ratio. That is what c equals 1 means. And velocities are just fractions of this. 99% light speed means 0.99. Half light speed means 0.5. The speed limit is the exchange rate between space and time. And massive objects cannot reach an exchange rate of 1 to 1 because that would require infinite energy. Massless objects must travel at 1-to-1 because they have no rest frame, no internal clock, no way to experience zero velocity. Think about that. A photon, traveling from the surface of a distant star to your eye, experiences no time. From its own perspective, if you could even talk about a photon's perspective, it is emitted and absorbed in the same instant. The journey takes zero time. The universe is contracted along its direction of motion to zero length. It exists in a timeless, spaceless state between emission and absorption. And yet, from your perspective, that photon traveled for years, decades, maybe billions of years. Time is relative. The interval between events depends on your motion. Now, there's one more thing I need to tell you. People sometimes ask whether the speed limit might be broken in exotic situations. What about quantum entanglement? What about the expansion of space? What about wormholes? Well, let me tell you about these. Quantum entanglement does not violate the speed limit. When two particles are entangled, measuring one instantly affects the state of the other, even if they are light years apart. This looks like faster than light influence. But you cannot use it to send information. The results you see are random until you compare notes with the other observer, and comparing notes requires sending a classical signal, which is limited by c. No message, no causality violation. The speed limit holds. The expansion of space is different. Space itself can expand faster than light. Distant galaxies are receding from us faster than light because the space between us is expanding. But this is not motion through space. This is space itself growing. The speed limit applies to motion through space, not to the expansion of space. And still, no information travels faster than light. We cannot communicate with those distant galaxies. They are beyond our causal horizon. Wormholes, shortcuts through space-time, are allowed by general relativity in principle. But every solution we have found that contains a traversable wormhole requires exotic matter with negative energy density. We do not know if such matter exists. And even if it does, even if you could build a wormhole, you could not use it to violate causality. The mathematics prevents it. You can have faster than light travel through space, or you can have causality, but general relativity is structured so that you cannot have both. The universe protects itself. Every loophole closes. Every attempt to break the speed limit fails. Not because of some law imposed from outside, but because of the internal consistency of the geometry. You know, I think this is one of the most beautiful things in physics. The speed of light is not a random number. It is not arbitrary. It is the rate at which cause and effect propagate. It is the fabric of space-time telling you how tightly woven it is. It is the universe saying, this is how fast now becomes then. And we are part of this. You, reading this, are moving through time at the speed of light, not through space, through space-time. Your velocity through space-time is always exactly c. When you sit still, you are moving through time at maximum rate. When you move through space, you trade some of that motion through time for motion through space. The faster you go, the slower your clock ticks, because your total motion through space-time is always c. You are always traveling at light speed, just mostly through time. And that, I think, is beautiful. We live in a universe where space and time are woven together, where motion mixes them, where the maximum rate of change is not infinite but finite, where causality has a speed, and that speed is the same for everyone, everywhere, always. This is not how we expected the universe to work. It is stranger, more subtle, more elegant than anyone imagined before the 20th century. And here we are, biological creatures, products of stars and chemistry and evolution, able to understand this, able to measure it, able to confirm that yes, this is how it actually works. The meter is defined by light. Light travels at c because it must. Massive objects cannot reach c because geometry forbids it. Because that is the structure of space-time, because that is the structure of space-time. The speed limit is not about speed, it is about the shape of reality. And we figured this out, we measured it, we tested it, we confirmed it to 21 decimal places. That is how it works, that is science.